So I'm come to color indices, and I said I will only cover some examples here. So it will be the whiteness index and the yellowness index and the alpha color. So I start with the whiteness index, and there's very often we get the question, what's the difference between the whiteness index E313 or the whiteness index CIE? And actually there isn't a difference. It's just another name for it. It's the same. And the application for the whiteness index would be for all products that are meant to be white. So it's very often used in the textiles, in paper, and in white plastics. But be aware, so whiteness index doesn't make sense for a blue product or something like that. And if you look at it, for example, for white paper, it's very often used. And you can really compare here recycled paper to universal business or premium paper. Just a moment, I have to have my laser pointer back. Yeah, okay. So recycled, universal or business paper here, premium. And there you get different values for the whiteness index. For example, here, it's sufficient to have only 55 because it's quite yellowish. And then it goes up until to 171 for premium white paper. Just to give you an example for the values for the whiteness index here. And so that means if you have a rather bluish white, the whiteness index is high. And if the white is a little bit yellowish, you get a low whiteness index. And besides, and actually for white colors, they're very often used also whitening agents, for example, in textiles, detergents, and paper. So they're even added fluorescent pigments to enhance the white appearance. And if you want to measure that, you would use another whiteness index, and that is the whiteness index from GANS here. This is another index, yeah, and this is really taking into account fluorescent effects. That means an effect that light, which is UV, which is the UV component of light of the normal sunlight, is transferred into the visible area, and this makes the white colors seem a little bit more bluish and such a little bit brighter. And to measure this whiteness, you need to have an instrument that can be UV calibrated, and you need a special calibration tile, a fluorescent calibration tile. And we are, for example, having that for the Ultrascan Vis and Pro and for the Agera devices of HunterLab. Now I come to the yellowness index. It's mostly used in reflectance, but it can also be used for transmission measurement. And that is a little bit similar in the application. It's used for white products, but that tend to be rather yellow. And important, it's not for really yellow products. So for example, it might be vanilla ice cream food here, or tablets in pharmacy, or plastics. Yeah, so it would say you use it for products that can yellow, that would be normally white, but that can yellow, for example, by aging, by contamination, by disintegration by light, or by disintegration by chemical processes. And here we have different methods. For example, the ASTM method E313, so that's yellowness index E313. That is defined for 2 illuminants, for D65 and for C. And sometimes you find the ASTM method D1925, which is only defined for C light illuminant C2. It's short named yellowness index D1925, but actually that was withdrawn in 1995. But still some companies use it because they're used to it, of course. And for the yellowness index, you would have 0 for a perfect white, and then positive values, the more yellowish the product is. And the last index I want to show you is the alpha index. And there's a funny thing with that alpha index because it has 3 names. It can be called alpha, PTCO, which is standing for platinum cobalt, and Hazen index. So we have these three names because for the American Public Health Association, so this is ARPA, a platinum cobalt solution was in 1892 defined as a color index. So that's a platinum cobalt here. And this was done by Alan Hazen. So this is why we have the three names. And especially the last name of it is often confusing our customers because we have also another Hayes index, and that's for turbidity. And you really have to keep in mind, Hazen is not the same as Hayes. It's something completely different. And if we have a look at it, where it can be used, so it can be used for very slightly colored solutions here. Here, 0 is clear water, and it goes up to 500. And there you can see it's a yellowish tint, but this gives already the number 500, and you have very slightly solutions for the lower numbers here. And just to show you the spectral plot here, you can see here we have nearly colorless solutions, and it goes to slightly colored yellow solutions here. And it's mostly used in chemical or pharmaceutical products, oils and plastics. And I have a display here again for 0 up to 30. So visibly you don't really see very much of a difference. And already the highest number is not really darkly colored here. So distilled water would give 0, and a saturated amber yellow would give the number 500. With our instruments, you can measure also values at 700 or something, but they are not defined by the AFA standard, then it's just for a comparison. So these were just 3 examples. Actually, there are really many indices which can be measured. There are all the standards, and they can be measured with our instruments. And well, it's mostly the application which is giving the right index for you, or the tradition for your for the industrial field you're in. Yeah, but our instruments can really measure nearly every index that is on the market.